I think, yeah. I think we're good. Okay. 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 We're live. Hi, guys. Hi, live stream. I hope, by the way, if you're on the live stream, I hope the audio is better because I don't know if you were with us last month, but we could not figure out the microphone situation. And so we just had like two tiny little, they looked like little, dots. Are those like the little gummies? They look like two little dots on top of that. And thankfully, Wendy Klein, who was our guest last month, she is a professor at Purdue, and so she put on the teacher voice, and we got through it.
I'll do my best to put on the teacher voice.
She said the same. She said it the same way. She said the teacher voice,
right. As opposed to the voice of doom. Doom. Oh. The kids in my class love it when I use that super low voice.
Yeah.
They crack up.
Oh my gosh. Okay, well, hi guys. Are you good? Okay. I was just making sure the live stream's good. Hi everybody. Hello. Let's see. We might have to pass this back and forth. Is that okay? Yeah. Oh, that works. I'm interviewing you CNN style, like we're on a morning show, the Today Show. I love that. Okay. Hi, guys. Welcome. We got a microphone this month. That's really exciting. I know. Woo! We got a microphone. I mean, I guess technically we had a tiny little one, but it was like the size of like those little dots candies, if you know what those are. I don't know if those are even good anymore or if those are like popular anymore. But so now we have a microphone set up this month. So you're welcome to the live stream. The audio is probably so much better. And to Rufus and Rachel and Sam and all of those with your new families, I hope you are, all of us send you our well wishes, and hope you are all doing wonderful with your new families. Before we get started, I do want to ask if anybody here did the City Nature Challenge this weekend and went out, yes, and took pictures. I don't know if you were following over the weekend. We actually broke records and we had over, I think, 8,000 observations this weekend, which is a record for Indianapolis. Maybe it's because the weather was beautiful, or maybe we just, I don't know, people moved and they like put bird feeders out this year. They were like, all right, we're getting so many birds.
There's bird observations.
It was everything. Birds. You know what? A shocking number of fungi. Shocking number of fungi observed this year.
Because Indianapolis has fungi.
You know, I would say Indianapolis has a few fungi. But so anyway, thank you so much for making this year's Indiana City Nature Challenge so much fun and so successful. You don't have to wait for the City Nature Challenge to participate. You can download the iNaturalist app and make observations and engage in citizen science at your own pace, at your own time, whenever you find the need or whenever you see something cool outside that you want to take a picture of and put on there. So I just wanted to give a thank you to everyone who participated because 8,000 observations is wild. So thank you for breaking records. And then with that, we can go ahead and start with our April book. And if you are like me, you might be missing out on like the fun and just all of the pomp and circumstance that came last year with the eclipse. And it was so exciting. And everyone was like so obsessed with the moon. And we were talking about the moon and it was in the headlines. And now a year later, maybe some of the hoopla has dissipated, but not here and not in this book club. We are going back to the moon. Here right now, we are going back to the moon. And with that, who is going to help bring us? You're going to help bring us back to the moon. So go ahead and our wonderful expert, introduce yourself and tell us a little bit about yourself and your background and how it relates to this book.
So I'm a jack of all trades, master of none. I started in mechanical engineering in robotics. I moved to working for the Congress as a material science expert. I worked for Johns Hopkins Sociology Department as a data analyst. I stayed home 10 years with my two kids. When I went back to work, we were here in Indiana, and I was director for research and policy at the scholarship agency of the state. Then I worked for a heavy engineering software company, and now I'm retired about 6 years. And in retirement, I take one geology course each semester. And this semester is isotope geochemistry.
Yeah. Which, by the way, this is me learning live that you can just go back and take classes. I mean, I guess I knew that was an option, but you're not just auditing classes. Let's be clear. You are doing the do. You are taking them for grades. You are kicking this class's butt.
Yes, I have an all A average, which is easy to do when you only take one course each semester.
Still impressive.
And I feel like I need to be a good role model to the other students. So I work hard, I work with them in teams, and I volunteer to go first for talks and things like that and show them it's not all that scary. So
You are every teacher's best student. You're everybody wishes they. Oh, teacher, do we like students who engage in class? Getting a head nod. Yeah, we like we like the kids who engage in class. So thank you for being a great role model, and thank you in advance for being a great expert. Okay, we're starting this with a pop quiz for all of you. How many of you actively track the cycle of the moon and what cycle it's in? Okay, we got 2 cheaters because I know you're astrophysicists. I know your background. But I do.
do I
Have
know what the phase of the
well,
moon is? Will I
yeah. No, well, no. Is this something that you've always done? But like, this is something I started doing when I was reading the book, and I actually found it a very nice and relaxing experience.
You know what makes you really lazy is Google, because and for me, my weather apps will tell me when I get up and look at the weather for today what phase of the moon it is. They tell you in your weather app, and so I've gotten lazy and I don't know what the phase of the moon is all the time, but I'm pretty sure I know when it's a full moon because Indiana drivers, you know.
Yep. When I get on 465, I go, full moon's coming up. And that's okay. You can start today. Hey, guess what? The moon's still there. You can start. You can start today, and maybe we start with the Google apps, and maybe we try to wean ourselves off. You know, we taper ourselves off the apps. But I love that so much of this book, and I think really in understanding the moon, we have to kind of study the Earth because they're obviously so interconnected. Let's talk about early Earth, because we think of the Earth and moon now as like, of course, they're a pair. They're a dynamic duo. It's peas and carrots. Always been there. Not really the case. So what was Earth like before the moon?
So early Earth was like hell. I mean, it's called the Hadean period. Um, early Earth was formed and hanging around while the rest of the solar system was still forming. The solar system formed out of a nebula. All of the, silica gases and all the other stuff in the nebula swirled first into a disk, and then the disk started coalescing. Gravity works remarkably well, and this stuff starts clumping up together relatively quickly, but still, it took something like 600 million years for the nebula to coalesce into a solar system. The earliest era on the Earth is called the Hadean era, and it was about 1 billion years long. And it's dated from the oldest rocks we've found on Earth that are meteorites. They have chondrules within the meteorites, little spots that you can date back to like 4.6 billion years old or something. And it runs right up until the first solid rocks on Earth, which, depending on who you ask, it's either in Acasta Shale in Canada, or maybe the Upper Peninsula of Michigan, or out in the Jack Hills of Australia, where they found these zircons that they can date back to solid Earth. And that's when they said, okay, Hadean era is over, starting the Archean era. So that was a very long time. And it was basically a sea of molten lava. By the end of it, we were starting to get these small continents that we now call cratons. The cratons are the core continent. So we have the North American craton. Not all of North America is part of that craton, but we're sitting on some of it with a bunch of eroded Appalachians over it. But still, we're sitting on the craton. And these cratons were alone in a sea of very hot magma, and even the magma is different now from what it was then. It was really quite amazing. We didn't have much oxygen either. It was highly reduced atmosphere. We had a lot of other gases that you really can't breathe, methane and that sort of thing, ammonia. Nasty, nasty place, that early Earth. So
Yeah, sounds pretty bad. Yeah, I'd probably give it a 0 star. Wouldn't want to go. But then I love how the book walks us through the theories of the impact, right? The impact theory and how my favorite, it started as the big impact. And then they said, no, 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 that's not enough. It's got to be the gigantic impact, the big, big impact. That was how we're going to describe it as we learn more. Beautiful, by the way, beautiful naming, not a read, this is not a criticism. Physicists, I love it. Keep doing it. But so we get, would you would you describe Thea maybe as similar to how early Earth was? They were two similar beings before beings. I don't know why I'm giving them life.
yeah, in terms of geologic content, they were very similar. A lot of the stuff that came together to form the inner planets of the solar system was very similar. The thing that's different is, of course, the size. They say that Thea was more Mars size now than, but I don't know what the size of Earth was then, because frankly, once Thea struck Earth, a lot of the heavy elements from Thea stayed with Earth and became part of our core, all the iron. Um, the moon is iron depleted. It was basically coalesced out of a lot of silica gas. So it's lighter in the sense that it doesn't have the iron core that the Earth does. But Thea, yeah, probably was fairly similar in geologic content to Earth.
Yeah. And so then I'm gonna skip over a little bit of history, like the whole like life happens. And even actually the book goes into detail about how the moon and the moon's effect on the water and the tides was necessary to stir up some of the elements that were necessary to create life, which I thought was fascinating. I had no idea. I think a lot of times when you learn about this in school, it's like, well, the fish came out of the water and then somewhere we happened. And the thought that we needed the relationship with the moon, early on to form the earth into what was needed to make life possible. I mean, we need the moon as it exists now. We needed the impact, but we also needed the moon. We need the moon currently as is, to sustain life and to make life. And so I'm going to skip over a lot of history. I mean, we can go back to it if you want to talk about it. Yeah. Oh, it is. Oh, what's your favorite part about it?
Oh, I just really like the whole impact, and then the whole theory of the heavy bombardment. So the disagreement on the theory about this large impactor Thea hitting Earth is not just that. I mean, the only people who dispute it are people who say, well, it was a lot of smaller bombardments, not as big as Thea was. But really, the evidence points toward a really big impact like Thea to have caused this. And then the late heavy bombardment, they say, well, there's dispute about that. No, there's no dispute about that. The question is, how long did the late heavy bombardment last? Was it really short and heavy, or was it over a longer period of time? And why would you all care about the late heavy bombardment just because I do? Well, the late heavy bombardment gave us a lot of information that we brought back from the moon. Gav, if you could pass around those two sheets, I have a bunch of illustrations that I wish the book had, so I brought them with me. So one of them is the far and the near side of the moon. The far side of the moon is so crater covered. That's the late heavy bombardment. Why don't we see that on Earth? Well, we sort of do, but a lot of our continents have been subducted and reformed and accreted, and all kinds of things happen to Earth that we didn't preserve a record. But the late heavy bombardment record preserved on the moon allows us to see the magma flows on the near side, the various elements that are still on the moon that have come out of the cracks in the moon's crust. And so I think the late heavy bombardment was a really sort of a useful thing for us to have available all these millions of years later. It only happened about 1 billion years after the formation of the solar system and the Earth. So it happened about 4 billion years ago instead of 4.5, could be like 3.8 billion years ago.
So the late heavy bombardment is something that happened on the moon and Earth simultaneously. Like, this is something that was happening.
It happened to all the planets On the inner solar system, what happened was as the gas giants started to move outward in the solar system because they hadn't found their places yet, they disturbed a whole lot of comets and asteroids and all that kind of stuff, and it came flying into the inner solar system. So you see this also on Mercury and Mars. They're a lot farther away from us than the moons. The moon's our best laboratory.
I love that.
This is too weird. Sorry.
Oh, poor Venus. It's okay. We'll give you your day in the sun. Well, I guess you have a lot of days in the sun. Okay. we can't do the jokes.
So I'd like to say a little bit more about what you did bring up, which was why do we need the moon? Heck with the moon. Why do we need the moon? We need the moon for other things too, because without the moon, we would have a crazy tilt, much tiltier than we have. The Earth would be spinning much faster. The Earth and the moon are in a system together of tangled angular momentum. So originally, the moon was a lot closer and the Earth spun a lot faster. And the moon has now moved far enough away that's in a perfect spot for eclipses. We have a moon that is the perfect diameter for the sun at their given distances from us. So when we have a solar eclipse, we get a total solar eclipse. Millions of years from now, the moon will have said goodbye and moved farther off, and the Earth will slow down even more. So our days will be longer, and the moon will be farther away, and our eclipses will not be total.
Okay, but I don't have to worry about that.
You don't have to worry about that. Don't go to sleep tonight wondering, will I ever see the moon again? You will.
Well, I think what did the book say? It's moving at like what is it, like 1.5 inches a year? Which I don't know, even over like one single lifetime, that's kind of a lot.
Sad.
It doesn't like us.
Would not like a 12-hour day with only 6 hours of sleep.
12-hour day, 6 hours. Yeah. Yeah.
Hours of sleep with a 12.
No.
It's good.
Yeah, 24 hours. Perfect middle. We like it. Well, but we didn't always understand how the moon rotated around us. I say us as like we are all the earth. We are all the earth and children of the earth. And I thought that whole section of the book where we're talking about just how, because the moon has been there, right? Like we're talking about these timelines that are hard to like actually fathom, right? I mean, we're talking on a timeline of, pre-Thea collision, and then we're talking about early Earth post collision, also not habitable. I mean, I'm assuming by any sort of life, right?
Right.
Yeah. So I mean, what kind of timelines we're working on when we're talking billions of years? Oh, you have numbers. She has numbers, y'all. Y'all aren't even ready. You thought this book gave you a lot of information about the moon. Y'all are not prepared.
This topic just fascinates me, which I picked up this book. But there's a time that geologists love because it's called the Great Oxidation Event. It's when sulfur bacteria really, really grew in numbers and started to create oxygen. So the Earth went from a really reduced state during the Hadean Archean, reduced meaning no free oxygen, you can't breathe, to a little bit more oxygen, a little bit more oxygen. And then we hit this explosion when the sulfur bacteria really kicked in. They convert sulfide to sulfate and free up oxygen. And that's when a lot of other life could really kick in. And one of the really cool things is that on some planet, on some solar system that's named like 1221b or something, they've found sulfur bacteria. So, I thought when we discovered life, we would find these, giant brain aliens who would know everything. And, they'd already have a long established situation and they broadcast radio waves so long ago that that's passe now. But no, the first life we find in the universe is the same bacteria that got us going.
If you didn't already know that from coming to this book club, you know now. Bacteria is everything. Bacteria, really, the root of all problems and also all solutions.
It's an amazing solution. This sulfur reducing bacteria is there.
So, going as Earth becomes habitable by life, including bacteria. We'll include bacteria. I like my gut. I'm going to include, I don't want them to rebel against me because they certainly could take me down. They outnumber me by too many. So I'm going to be nice to my bacteria. I'm going to give them fiber and be nice to them. And yeah, fiber, yogurt, be nice to your bacteria. Um, you know, early, the book talks about like early civilizations, ancient civilizations, trying to understand the moon. I don't even know trying to understand the moon, trying to track the moon. And as the book, I think correctly suggests, and maybe this is a hot take, I think it's totally reasonable to assume that the earth is the center of the universe. I think that's totally reasonable. If I was living way in the back whens in these ancient civilizations, why would you think any different?
It's also normal to assume that God or gods are essentially nature gods. This one controls the weather, this one controls light and dark, this one controls the waters, this one controls, I don't know, whatever. It just seems like a natural assumption that there are multiple gods and they each have their own silo they stay in and they control whatever controls your life, right? So, yeah, those are two very natural assumptions. One of the biggest things in their lives was lunar cycle calendars. I mean, how else do you know when you have enough light to hunt and when you should stay home and take care of your wife and all the other things the book mentions? That the moon was a god or a goddess, and often a goddess because associated with fertility and women and that sort of thing. So those are two very natural conclusions.
Yeah, absolutely. But that caused a lot of early misunderstanding of how, as we looked up to the stars and as we started to understand the moon and the moon cycles, and we started to try to think about the rotate, like, okay, so the moon's rotating around us, the moon's moving, and then also maybe we're moving a little bit. But then how do we both move in circles simultaneously, but we're not rotating around anything at this point. We're still in the middle, but we're also moving and the moon is moving. So can you talk to us about these epicycles and how we came early on, we said, well, just everything's moving in circles around a circle and everything's a circle.
Well, since it was natural to assume that the Earth was the center of the universe, that's a theory, right? And you're going to test your theory. So back then, they didn't really have the scientific method. So what they did was pretty hard nailed that theory and figured out how everything else had to fit. So they made these epicycles, which is on the paper I just passed around. Essentially, let's picture me walking in a straight line, and there's my husband. He's going around me. Now I'm going in a curve myself. He still has to go around me. So sometimes he has to circle very wide, and then sometimes he has to run very fast on the inside to come back. These are epicycles. They made up these epicycles to explain what's going on with the Earth, the moon, and the sun. There is one college in the US. It's St. John's College of the Great Books curriculum. They have epicycle races every year. I just thought that was a hoot. Anyway.
So what are epicycle races?
Yeah, where one person's going around another person who's going around, and it's just very confusing.
And dizzying?
Yeah, that's a college where you have to learn Greek and Latin just to be able to read your textbook. So speak of dizzying.
Yeah. Yeah, snaps to them. Good on you, kid. Good on you. I tried Latin and I couldn't get past it.
I did Latin, but not Greek. But anyway, it's all Greek to me. So they had these contorted epicycles. So the first guy that came up with this is Hipparchus, I think. And then the next guy that came along, Ptolemy, he was like, yeah, no. So yes, the Earth is still the center of the universe, but it stays in one spot. Not everything is moving. So let's get less jiggy. And then, of course, that completely fell apart also because it can't explain half the stuff we see. And so Copernicus came along and made the heliocentric model. And that was like 100 years before Galileo nearly got executed for saying, Copernicus was right. Of course, he did it in a really nasty way, I'm told. He he published something and he was told, don't publish that. And 17 years later, he published something even more nasty and was not keeping this sort of stuff to himself or even just putting it in scientific journals quietly. But anyway.
There's a lot of scientific beef, though. A lot of scientific feuds.
Oh, we don't have anything like that anymore, do we? There's no disputes about the scientific method and what's correct. Ah.
Yeah, like the big impact theory. I mean, in the Great Bombardment, there's no disagreement anymore.
You know, it's funny. They like to say there's disagreement, but the disagreement is so small. It's like 99% yes and 1% quibble because I like to quibble.
Yeah, 9 out of 10 dentists agree you should use toothpaste. There's always that one, and maybe it's just in every field. There's always that one. Well, and so we finally moved to the heliocentric model, and we're cooking. We're getting somewhere scientifically. But I think it's so I don't know. I just think it's so interesting to think back to how they were. I mean, you say that, there's no scientific method, but I mean, with the tools that they had and the constraints that they had on the concept of research, I mean, they really were putting, I mean, in Galileo's case, they're really putting their neck out there for their thoughts and their beliefs, right?
It was only in 92, I think, that the Vatican said, yes, okay, we did a wrong thing to Galileo. He's right. 1992.
Was it really 19?
350 years later. Catholic Church kind of moves pretty slowly, but
Okay, think of how far the moon moved away in that period of time. Like over 300 inches. That's a lot. It took them that long to apologize. But
to go back in time to before the crazy epicycles and the Ptolemaic model and that sort of thing, to the henges, the book raises a number of like cool henges you can find. There's way more than that. We went to a couple of random ones in Scotland that aren't even on the map, as far as I know. And but there's also henges in uh, Turkey, Sweden, India, Japan, the Golan Heights, Spain, the one in Germany they mention in the book. And there's a Swedish Trondheim chariot, which is it's a chariot, and in the chariot is a model of the heavens, and it's being drawn by a horse. But it's very similar to that Nebra disc in Germany and the Mayan calendar disc and that sort of thing. So, many, many, many cultures, because humans are like this, need a calendar or need some organizational unit. And you've got the sunrise and set for the day. The moon gives us the month, and it gives us often the seasons as well. So very, very useful. Many, many cultures. You could do I'm sure there are cultures I don't even know about that have these henges or discs or whatever that track our calendar.
it sounds like you guys were doing some archaeological work. Sounds like
We just went to Scotland for the fun of it and looked up what henges can we go to without going to Stonehenge.
honestly, good idea. Yeah.
Path. To be off
Yeah.
the beaten path.
No, I like that. But I want to use this as our lead into our first turn and talk. And I want to ask, because maybe some of you are familiar with the debate on whether we should get rid of daylight savings. You're familiar with the concept of daylight savings time, right? You're familiar with the concept of a leap year. And the moon does establish our calendar, but it's not perfect, probably because of human hubris. We just can't help ourselves. We can't just do what makes the most sense. We got to make it complicated. So I want to ask you all if you think it would be maybe better to go to a leap month system instead of a leap year system. Can you describe to us what it would mean for us to be on a leap month calendar before we go into this?
I think it would be really difficult, except you look at France and they take the whole month of August off. So yay, let's do that. It would only be a 28-day month or something. But another more recently proposed calendar was a 30-30-31, 30-30-31. And with that, you would have a leap week every 5 years, which sounds like fun, a whole leap week. Maybe we could get an entire week off, but it's only every 5 years. So somehow we have to make the adjustment for leap something or other. But it would be interesting to think of what it would be like to be on another calendar.
So in our turn and talk, I want you to consider, maybe we consider both options and we put this to a vote, because obviously we are in control of what calendar we adopt. Uh, leap week or leap month, or do you really like the leap year? Leap month, leap week, leap year. Those are your options. Discuss, and then we're going to vote for the entirety of the globe.
Leap year is obviously we only get a day every 4 years, so it's not really. I mean, it'd be fun to have a whole year, right?
Yeah. Yeah, leap. That's true. Leap day, leap week. Yeah, leap day, leap week, leap month. Bless you. Okay, so I'm gonna give you guys like 5 minutes, and then we have to vote for the world. No pressure. Okay, and so then while they're gonna talk about it, we can stay on live for the live stream. Do you have a preference? Do you wish we change? Do you want to change the leap? Are we initiating change?
A week would be enough that you would actually have to do it, whereas a day is just kind of gets washed in, and a whole leap month just seems like, gee, I don't know. How often would we get that? Once in our lives, twice in our lives? I don't know.
Yeah, not as often.
Ask a leap baby how they feel about being born on February 29th and whether they feel young or what.
I'm only 4 years old. Yeah, going to bars must be really hard. They're like, you're actually only, 4 years old. you're 8 years old, sir. You can't drink here, but you have a college degree. Yeah, but I have back pain. So tell me that. Do you think we ever would change the calendar?
Well, we have in the past, so I can't say we would never change. I mean, who knows? We may have colonies on the moon or something, and there might be reasons to do things, especially, live on the moon, you're on the lunar calendar. So part of the impetus for thinking about changing the calendar was the thought of a lunar colony and how would they keep time, and would they have to do the same stupid stuff we do? We don't know.
I mean, maybe for a while, starting out, but that's such a good point.
They get isolated for some reason, or if we have a Mars colony that's effectively isolated, they'll need a new calendar. Apparently humans like to sleep, or like a day that runs 22 to 26 hours, but that's because we've evolved on this planet.
So do you think a lunar colony would eventually over time adapt to a lunar calendar regardless of whatever Earth calendar we have?
Not necessarily if they're still like, they're still solid colony like the Americas were when Britain first 100 years of Britain's ownership of us. But eventually over time they might throw off the yoke of oppression here on Earth and do their own thing. I don't know.
And that's where Maurice Broadus comes in. And we talk about starting a colony on another planet.
That's where water on the moon comes in. Can we do this? Is there enough minerals? Is there enough water? Is there enough whatever to continue to try and separate from our, evil overlords or whatever?
Yeah, because what are you going to do? Come and get me.
The moon has one advantage. We are a serious gravity well. They can essentially drop bombs down on us, whereas we have to expend a lot of energy to send any weaponry up there. So just like England trying to hold on to its US colonies, it's going to be a lot more difficult for that tiny island to hold on to a big colony than it is for the colony to break away. So
I had never thought of that.
or a giant gravity well, if they can heave something off the moon, which is pretty easy, it'll go down to Earth.
Oh my God.
Uranium on the moon now, or any
Okay, really?
nuclear. I don't think there's any nuclear weaponry on the moon. I know. They're just dropping rocks on its rocks. Look at the Chicxulub impact that killed off all the dinosaurs. Big enough rock. All they need is like to shoot a mile of rock into the air.
Oh my God.
Enemy topic. On the moon, trying to annihilate the Earth.
You're not even. No, but they're making you their military leader.
Right? I can't take credit for this. This is I think one of the posits of The Moon is a Harsh Mistress by Heinlein. They established the lunar colony, and then they decided we had enough of Earth, and we're going to threaten you with throwing rocks down there.
And it would work. It would work.
No, it's science fiction. I don't know what would work militarily versus the attitudes of the people and that sort of thing.
I think you're onto something, though. This might be used in a case study in the future.
Don't let anybody throw rocks at us.
And they might find one big enough to make it a problem.
Yeah.
Or worse, we do find the uranium.
Oh, there's water, but there's also uranium. Oh no.
Why not both? You know?
Ugh.
Well, so then I guess maybe we have to consider, do you think if we did have a moon colony, say that did happen in a reasonable amount of time, do you think we would adopt a new calendar just globally to accommodate something like that?
If we actually grew as a whole or a civilization, we might consider that. I mean, we certainly, you can look at some of the calendars on Earth now of other cultures. They're very lunar based already. The Chinese, the Islamic calendar, the Hebrew calendar, they're all lunar calendars and they get along just fine celebrating Eid in July or Eid in, December or whatever. So it's not like it would be a horrible new thing to change our calendar because not all the Earth, I mean, business wise and functionally, we all have the same calendar, but holidays and religions and that sort of thing, we adapt just fine for a different calendar. So it could happen.
Yeah, that, you know what, that's true. If we are one thing as a species, pretty adaptable. Yeah.
So
Oh God.
I have to be.
That's different.
I know, right?
Yeah, we'll have Gabe Filippelli on for that one. We can talk about that, or maybe our Dune expert.
Let's think about several thousand years from now. Let's hope we're all here, and the moon is a little farther away, and the Earth is a little slower, and our day is a little longer. That may force us to get a new calendar already, anyway, if we have a slower turn to the Earth. Now we're not going to change the speed at which we go around the sun, so certain things will change. The day length will change, but not the year length, and that sort of thing.
Yeah. Hey, fun times for a person who has to come up with that calendar. That is not you and is not me. I mean, what kind of timeline are we talking? Hundreds of years? Thousands of years?
What did we say? An inch and a half every year.
Yeah.
So, thousands of years.
Okay. Yeah.
We'll add an hour or something.
Okay. That sounds like not my problem.
That all we do is slow down. The moon leaves, we just slow down. I don't want the moon to leave. I don't think the moon wants to leave either, because what happens to it when it leaves? I mean, eventually it gets far enough away from Earth's gravity that it's essentially like a really large asteroid. And it could bang into something else big and cause another Thea. Because it could be attracted to the gravity of some other planet. It could be captured and go around, which is very nice. Or it could not get captured and just drive right in. I don't know if you saw the Shoemaker-Levy comet footage hitting Jupiter, but it was really amazing. The Shoemaker-Levy comet that everybody was very familiar with eventually succumbed and drove right into Jupiter and sent, it's almost like skid marks, when you skip a stone. You can see the skid marks from it on Jupiter. Yeah. Look up the comet hitting Jupiter and you can see this little footage of it doing that. Yeah, it was cool.
Cool because it's not Earth, not me.
And in the Shoemaker-Levy comet, it's like, yeah, I'll miss you, but that was cool.
Yeah, nice, but I got other places.
Went out with a bang, whatever.
Yeah. Oh my gosh. I wonder. What were you saying?
I was wondering what topics that we talked about by email that we didn't talk about.
We got time. We got time.
Talk about Thomas Harriot. He's a pretty interesting guy.
I loved his chapter in the book. Yeah. Okay. We're doing this. I hold the reins here. Okay, guys. I think we're going to a vote. And I think we had a great discussion. I think there's a middle ground. Okay. Raise your hand if you vote for the leap week calendar. You want a leap week. We got a couple hands. All right. We got 3 hands for the leap week. Leap month. No leap month. Okay. We got a leap month. Do we have any? Are we happy? Anybody happy just with the leap year, the leap day? We got a lot of leap dayers. Okay. The leap day. Hey, to the guy who landed on that option, you're welcome. we all agree in this room, if that matters to you. Your spirit.
Now we don't have to let the US know or anybody know that we're going to change it because it's going to stay the same and it has our permission.
Yeah. Hey, every federal government, you have our permission to keep the calendar. You're welcome. But you brought up a really great point. Oh, yeah. Mm, yeah. Yeah. Yeah, the 30, 30, 31. But that's a really great point.
Year week. So every 5 years, you got to add a week if you do 30, 30, 31.
But that's a good point. We wouldn't get the week off, especially in America.
I don't want to go there.
Yeah.
I'm going to preserve my happy place.
Okay, we got vote converters. Okay.
That you have to have an extra day, but you can subtract the day off.
Oh, we are under this. Okay. Yeah. Yeah. Okay. So now, hold on. Andy brings up a great point. We can also remove a day, and we are now okay. We have all. I'm saying unanimously voted. The day we're removing is tax day.
Tax day.
Hey guys, you're welcome. We made that decision for everybody, and it's definitely going to go into effect ASAP, immediately. The authorities are on it because they're watching this. We've removed tax day, guys. Good. Hey, good work to the book club. But you brought up a really great point that I hadn't thought about, and that is a lunar colony. We might have to go to a lunar calendar if we really established a lunar, like a large, well-established lunar colony. That might be something we'd have to consider. I hadn't thought of that.
Well, you never know. I mean, I was thinking of it in terms of, the U.S. colonies of Great Britain, and if the lunar colony is advanced enough and they have enough resources there, water and whatever, they may decide they're sick of our nonsense down here, and they want their own calendar because they don't have anything like winter or spring. So they may want a different calendar, and then maybe by then we'll all be like kumbaya together, and we'll all decide on a mutual calendar, or maybe the moon will just decide they're sick of our stuff and they can throw rocks down at us with very little energy expended, and so buzz off, Earth. We're good. Hey, Fritz.
Yeah. Mm. Yeah.
Yeah, there's a
That's true.
19-month calendar that you can go off of that's essentially a generation here on Earth, because we think of things in terms of 10 or 20 years also. So there's a lot of possible ways to synchronize things.
But maybe as the colony conversation, comes, and again, probably not a problem for me, but we're making a lot of big decisions in this room. So, hey guys, we might have to reconvene. I'm just warning you now because you're making the call. Sorry to tell you.
That brings up a point I did want to make about the overview effect, which is brought up in the book. And it's the feeling astronauts have when they're on the moon or in space and looking down on Earth, and they get a profound appreciation for the Earth and a profound awe. And I feel like both astronomy and geology, with its distances and its time scales, gives me that profound awe and appreciation for the mundanities of life. I get up, I do dishes, I sleep at night, I have a cat, and it's there's a lot to appreciate considering how far away things are and how old things are.
I agree, and I think that book, just reading this book gave me a little sense of that, to the point I had to put it down a few times because I was like, it was one of those like, whoa, man, this is too much for my little human brain right now. But I want to talk about one of the characters. This is a real person in the book who really did not get the credit they deserved. So introduce us to them. Let's talk about it.
Has anyone heard of Thomas Harriot that hasn't read the book? Yeah, so I never heard of the guy before I read the book. And Fritz is in his line of work, so I can imagine that Fritz would have heard of him. And I wished I had heard of him. What's that? Ah, yes. He's I can't he's a sort of a jack of all trades. He's made his mark in math and astronomy, and he was the first guy to look at solar sunspots and watch how they moved and deduce that the sun is turning on its axis. He made a map of the moon by looking through his telescope. I think he's from like the 1700s in England, and of an aristocratic family, of course, because anybody who had that kind of leisure was, you know, had people working for them on their farms and whatnot. Um, he also discovered some of Jupiter's moons and some comets, and he developed the greater than and less than symbols. He also did a first crack at binary system, and took a crack at calculus through looking at infinite series. So again, quite a jack of all trades and very modest. Didn't care whether he published. Didn't care whether anybody knew he did anything. His friends were all telling him, "Look, you got to publish this stuff. Get it out there." It's like, whatever. He would rather make precise and careful little drawings in this giant book of his than publish anything. And he has some remarkable drawings of sunspots and the detail of the moon and that sort of thing.
Yeah. Well,
James Thomas Harriot. Thomas Harriot.
yeah, and I like that the book gives him the credit he deserves. They're like, okay, Galileo, cool guy and all, but this is really he should have gotten a lot more credit than he did. And here we're giving him his little moment. Yeah. Mm. Yeah. Interesting. Yeah. Yeah, definitely was a scientific, a scientific arms race. If I were to write a book, I have decided that it's going to be about this interplay between science and research and power and authority. If I if I write one, because I have lots of thoughts.
I had a great experience with that. I worked for Congress for 5 or 6 years, and it was an organization called the Office of Technology Assessment. It's a congressional agency. They gave us a mandate to publish on a particular topic, and it took a year long. We had guests from all over the world we could interview, all kinds of seminars and whatnot. And we would come out with like a 12-chapter volume that a senator or representative could stand there and wave around, and then a 20-page summary that their aides could read, and then a one-pager for the actual senator or representative to hopefully read. And we actually influenced a lot of policy. When I was working for the agency, superconductivity came up. High temperature superconductivity was discovered, and it was an amazing time. It was called the Woodstock of physics, I believe. And people were going to these conferences and staying up all night and calling back to their labs. Have you confirmed it? Have you confirmed it? Did you do this? And yeah, it was very exciting. Physicists were getting data back from their labs, and very exciting time. And the Congress was all, how much money do we need to throw at this? Are the Russians going to beat us? How about the Japanese? Are they going to beat us? So we were essentially in an arms race with the European countries, Japan, and us to throw money at high temperature superconductors if it were going to come up with great new technologies like high speed rail for cheap and that sort of thing. So, but it was a fascinating time, and if you can interview me for your book on research and technology.
I was going to say you might be first on my list because I think this might turn into a book.
Some other friends I had at that agency who were working on even cooler topics, and that ended up in less regulation of the telephone system, less regulation of the aircraft system, all of that stuff. But, yeah.
I want to shift gears and stay in this little research bubble. I want to talk about the research being done on the moon rocks we have. I didn't know this. In the book cites like an 800 pounds of moon rock at NASA that we have to study. Some of it already studied, some of it being studied. Um, Sounds like we have a lot of moon rock. But what really can we learn from this rock that we don't already have? I mean, should we go back to the moon? I mean, is there really a purpose? And that is what I would like to turn to you all, and then I want to come back and get your opinion because I know you have thoughts on this. And I was going to ask just you, but I realize this is probably a really good turn and talk question. Should we go back to the moon? Because I mean, 800 pounds, 800 pounds of rock—that's a lot of rock. What what are we going back for? And this is just me. Hey, listen, I know there's probably a valid research questions, but I want to hear you guys and I want to hear your thoughts. And if we are going back to the moon, should we just start stripping it for parts? I mean, you know, what's so wrong with mining the moon for money? What's so wrong about that? I know there's probably a couple guys named Shmilon and Chef Shejosh that would probably be down to do that. They would love to scrape it for parts. So should we go back to the moon? And if we do, why not mine it? I want to give you all a couple minutes and then we'll come back and we'll oh, the moon billboards. That is an option. Yeah. Yeah. You know what? There's a lot of ad space. Not the Amazon smile on the moon. Oh my gosh. Okay, let's start with mining and then we'll go to billboards. So I'll give you guys a few minutes to discuss this idea, and then we'll come back, and then we will send our answers to NASA. I mean, is there really much more that we could gather?
The Chinese mission just brought back 2 new minerals that we don't have on Earth.
New minerals.
Total of 8 new minerals that we don't have on Earth.
What?
Yeah, minerals. Minerals are combinations of other, molecules and atoms. And on Earth, they form in certain gravity and certain locations. And I mean, there's a mineral that's called eclogite. It's only found almost close to the mantle core boundary of the Earth. It's metamorphic. It's formed really deep. It's a beautiful, beautiful, like sparkling pale green, and it's just a gorgeous mineral. And it gets exhumed every so often, but it only forms down there. So it's not at all unlikely that the moon would have the same combinations of atoms there, but form different minerals. And indeed, we have found 8 of them. The Chinese found 2, and or 3, and the Americans and the Russians found 5 total, but I don't know who found what. So why go back to the moon? Well, there's new stuff there, and it's again a moon race. Now it's including China as well as Russia and us, although Russia is kind of fading. It's doesn't have right, not a lot of resources anymore to throw at the moon. But yeah, so and other countries, India is gone too. So there are contenders. There's a lot of patriotic pride in going to the moon. And there's, like I say, these new minerals, and we the U.S. have never been to the far side of the moon. Can you believe all the missions?
Wait, really?
Some of the astronauts begged to land on the far side of the moon, but we always chose a place we could see. Part of it is because it's very craterous on the other side of the moon, and it's really, it's tricky to find a landing place, probably at the border of the near and far side at one of the poles. And I think that's what the Chinese did. But, for conquering new things, it's like, it's no worse than, some other Guinness Book of World Records. Hey, I ate the most peanuts of anyone ever. We went to the far side of the moon, that sort of thing. So, so yeah, there's reasons good and bad to go back to the moon. I personally, with a great love of minerals, I sent around on those sheets a picture of troglodyte. Troglodyte, I think it is. It's one of the new minerals they found on the moon, and it's gorgeous, sparkly. It's white and tan. It's really
That's what's going to get people to want to go mine it.
well. I don't know. Mining really, it's not for the prettiness of it. Although you can sell jewelry for quite a bit of money that's both pretty and lunar. But it's also what can we mine that's useful. And There's probably manganese and magnesium and a few other things. Not much iron. That's what makes it very difficult to make structures like steel that we have. So I'm not sure how much mining would net us, but you never know. There could be stuff up there that I haven't looked into mining the moon myself. I mean, I love the whole idea of going bouncing around the moon and exploring, but I'm really not crazy about either turning it into a bulletin board or mining it to the point where it's like you've disturbed our gravitational dance, and now the moon is gonna come crashing in or go flying out or whatever.
I mean, could
That's
happen.
a good thing. We got a good moon. Moon's right size in the right spot. I want to keep it that way.
Now, could we do the opposite? And could we take a ton of mass to the moon to try to keep it where it is and not go away? Or do you think that's
Drop more mass there. I don't know. That seems like one of these climate solutions where, like, you put a big um, umbrella over the earth so it doesn't warm up as much. It's like, who wants to live with that? I want the sun. I mean, there's all kinds of engineered solutions to problems out there that probably cause as many problems as they solve.
I think this takes us back to our and to engineer is human. I think where we were talking about Matt Sowers was talking about how sometimes you can engineer a solution that technically solves the problem.
Now, one of the solutions they're engineering for too much carbon dioxide on the earth, I think is pretty cool. I still don't know what its ramifications are, but in Iceland, they're doing carbon capture by essentially pumping soda water into their ground because they have very mafic minerals all through Iceland because it's on a rift and it's just barfing up ocean basalt. And if you put that carbon dioxide down there, it the minerals down there want to bond with it and they'll keep it locked up in there, which, I don't know if that has any ramifications for Iceland or anything else, but so far they're doing an experiment of carbon dioxide pumping and carbon capture that way.
That is really cool.
Yeah.
We should try that in Florida.
Yeah, there's whatever rocks there are in Florida are probably not the same kind of rocks there are in Iceland.
No, true.
Maybe Hawaii would be. Yeah. Hawaii is apparently an incredibly deep magma chamber. They found tungsten, which is really weird. They found tungsten in these Hawaiian volcano emissions that comes from the boundary of the mantle and the core. The iron core and the liquid mantle. That is really deep. If that's a hot spot, that is a deep hot spot. I know. Hawaii and Iceland are really unique spots on Earth.
Have you been to Hawaii?
Yeah.
Oh, you have. Oh my god.
Yeah. Usual in Hawaii, collect lava, and we walked out actually on an active volcano. It's really cool. Standing on the edge, wearing soaked bandanas so that the back spray of hydrogen, the sulfur gases coming back, wouldn't burn us. And yeah, it was amazing. It was amazing to be able to walk out on that volcano. So the Big Island is erupting out the side at the moment. The Big Island is actually moving along. So there's another island mount growing off of the Big Island. So there's going to be a new island soon. It's not above the water yet, but it's there. And, that the lava that's coming out of the side of the Hawaiian volcano on the Big Island it's this soft, very slow flowing. So it hardens enough for you to walk on it, but you can see it glowing in the cracks between your feet because the top 12 inches or so is solidified, but in the crust, in the cracks, you can see it's still red under there. And it's pouring into the ocean. And as it pours in, it makes hydrogen sulfide, sulfuric acid coming back at you. I know. It's really amazing. And Iceland's amazing too. They have their whole island is heated with geothermal because, yeah. It's a really neat place. Yeah, and all those breweries there need all that energy. Yeah. So both very cool places on Earth. Two of the other cool places on Earth are on the paper I passed around. They're called Large Low Shear Velocity Provinces, LLSVPs. And what they're saying is that when you send a shear wave through the Earth, like from atomic testing or an earthquake or something like that, it hits these provinces and it slows down. So you can actually map where the waves slow down. So these lumps are thought to be remnants of Theia. Yeah, there's two of them. There's one under Africa and one under the Pacific, and they're very deep in the earth. They're above the core, but they're in the mantle, and they're still solidified. They're harder than the mantle. Mantle is kind of soft and squishy, like mayonnaise in a sandwich or something. And these large low velocity provinces are one piece and solid, but they're really irregular and weird looking. You can see in the drawing that I passed around them. Yeah.
I'm gonna have to go find that.
Yeah, but they are pretty much a good confirmation that something big struck us, not a whole bunch of little things, and really went deep in and became part of our core.
Well, that's how we went from the big impact to the gigantic impact.
A Mars-sized thing hitting us would destroy the Earth now. You know, it would vaporize us all. And I mean, even one that killed the dinosaurs a couple miles across would be very devastating for human life too. So
Yeah, can't imagine.
not to live in the late heavy bombardment.
Now, can we predict future bombardments?
So
Do you think?
the solar system is pretty solidified, and there's nothing really nearby us that, you know, like the nearest galaxy, Andromeda, is 4 light years away. And even if it shot out debris, it would be pretty broken up and reduced and whatnot. So I really don't think that there's any kind of circumstances that mimic the early solar system that we're going to be exposed to, other than man's capacity for destruction. You know, my dad worked for the Trident submarine program, and we used to go around to churches and give a talk, and he would say, well, you know, nuclear weapons are on the earth. The United States has an obligation to control and direct this. And I always said, yeah, but we don't need the capacity to destroy the earth 400 times over. Wouldn't like 2 or 3 times be enough, and we could save the rest on the money? But you know, it was a good.
Well, what do I know?
Right,
What do we know?
right,
Other than changing the calendar.
right. Let's change the calendar. Maybe that'll help.
Okay, I'm curious to hear because I hear spirited conversation happening in the back. Y'all, I'm hearing some spirited conversation. Are we coming back to are we going back to the moon for research, and are we mining, are we stripping it for parts and or putting a billboard on it? I like the Amazon Smile idea, but don't tell Hefe. Yeah. That's a good question. Is there anything to strip for parts and mine on the moon? We have an answer in the back. Is the answer yes? Oh, all right. Helium-3 for nuclear. Oh. You said the word cheaper. I'm sorry. Cheaper to mine helium-3 on the moon, bring it back for nuclear power.
I think we might be.
Oh my God.
I think we might be running out of helium sources here on Earth too. It's not something that, I mean, once it's gone, it's gone. It's a volatile, it takes off. Most of the volatiles of the moon took off when it was formed. If there might be some in the moon, I don't know. Also, the basalt that's on the moon probably has some iron and magnesium, but it needs a lot of refinement to get out, because with no iron core, it's not going to be just laying around.
Oh, so the helium-3 comes from the solar wind trapped in the soil of the moon. Okay, but might be worth mining. What I'm hearing is, okay, I'm hearing one mining argument. But what about research? Is there still stuff to be learned on the moon? Yeah. A radio telescope on the far side. We were just, yeah, that would be a great idea. Radio telescope on the far side of the moon. Yeah.
We don't know much about the far side of the moon. I think the Chinese are the only ones who've been near it. Our astronauts begged to go to the far side and they were turned down. It's very, I think, difficult to land on as it's more crater pocked. But yeah, we still haven't, we don't know much about the far side of the moon, walking around on it kind of thing. What? Yeah. Exactly. Yeah.
Yeah, well, yeah, that's true. On the far side of the moon, direct communication would be really tough. I mean, I think you said the Chinese maybe landed right on right on the edge. So you can still be, yeah, right on the pole. Oh, couple satellites. Okay. Yeah, come on. We're not building cell towers on the moon, guys. Yeah, cell towers with microwaves all around the moon and satellites. Okay, hold on. We're coming up with a good picture. You guys could be paid as consultants. You might want to keep these ideas to yourself. Yeah. Yeah.
Personally a big fan of exploiting the moon. A lot of times we do things where we don't know what the results are going to be, like bringing snakes to Australia or whatever. But I rabbits to Australia. Yeah, I even less would like to see it become the Amazon Smile or some other, buy Pepsi or whatever kind of thing.
That actually happened. And he sent it up there, crashed. But that's the thing. Oh my gosh,
Okay, so now we're sending things to the moon to leave. I mean, I guess that's kind of like a romanticized thought, like leaving your ashes on the moon, but I feel like there are a lot of problem. So we're using it as a landfill. We're just going to put organic matter on the moon. By the way, how much of it is just going to, you know, what? What is this, a U-Haul storage facility? We're talking about the moon, like it's just got like a little.
Or like a morgue or
A morgue. Yeah.
you can picture billionaires wanting to go up there and like pay for something and be like, okay, this is our spot. Apparently the government something there and back in there.
What?
Yeah.
At the end of the book, you kind of talked about how the agreement in place
Yeah.
to protect your equipment once it's up there.
Mm. Oh.
Somebody with nefarious purposes would claim a specific spot and say, hey, when we're coming back, we're claiming this spot that nobody else can near our safe.
Okay. So planting equipment on the moon and saying this is mine. This is mine now. You can't touch it. I guess because even if you're not going to use it for research purposes, okay, who's going to go check that equipment's functional? Hey, who's taking their trip to the moon to go do the rounds on all the rovers and all the equipment to make sure it's working and that you're actually getting data for it? Who's going up there? Are you going up? Oh, that's happening right now. Great. To claim a crater.
Looks like our first.
Oh.
Yeah.
Okay. Yeah. M for moon. Oh my gosh.
First crewed mission to the moon in the Artemis series is going to be next February. So,
It got delayed, right? Wasn't it supposed to be this year?
but we've got a bunch of missions planned through like 2035 or 2037 or something. A whole lot of Artemis going on
Is that the goal of Artemis? Is this me maybe asking a stupid question?
to begin our moon race again. Yeah.
Oh, okay. I did know that. Did not realize that the race, I guess the race is already on and the race is already lost effectively.
India's going to get in on this too. I don't think the Russians have got the oomph anymore, but it's always possible that India and Japan will kick their heels into this too. So
How do you think and we can just open this up. How do you think the moon race of, we'll call it the modern space race maybe. I don't know if that's how it will be called in history. Mr. History teacher, you'll have to tell me in 30 years what they call this in the books. How do you think this is going to differ from what the space race we saw in the 60s and 70s? I don't know. Is that too big of a question? We were changing the calendar 20 minutes ago, so I feel like this is a good group to ask that question. I would love to hear it. Yeah. That's, you know what? Yeah. So the first space race, got there, said, put the flag down, we took our little selfie, and then we said, bye-bye. But we're not coming back home on this one. We can't afford to. Yeah. Yeah. And apparently now I know that we have to leave a lot of big equipment if we want to claim a big spot, I guess, on the moon. I mean, is there moon law? Are we going to have to start international moon law? There is moon law. Like maritime? Yeah. Okay. Maritime law is moon law.
we need law like we have for Antarctica, where we can all get along and establish research base and stuff like that. It's a harsh place. Really should come up with something more like that than the law of the sea.
Use Antarctica as a model. Hey, any lawyers looking to establish an entire theory of law? I mean, somebody has to be already working on that, right? That cannot be. Yeah. Planetary protection. Oh my God, because we're beyond the moon. Oh my God. We're already thinking about Mars. This book's focused on the moon. I can't think about Mars right now. Okay, we send the lawyers to the moon. Okay. Again, we're coming up with really good ideas here. You guys might want to stop. You're going to get a call from somebody. I don't know who, but you're going to get a call and you're going to be asked to consult, and you better argue a good rate because you already gave them a lot of good ideas.
Keep thinking of this like people who go and put their blankets down for the 4th of July parade. All we need is a big enough blanket to cover the moon and we're all set.
I love it. We'll put an umbrella on the earth so we can fight climate change, and we put a blanket on the moon to protect it, like a moving tarp. I love it. And I love how, I mean, obviously we, reading this book, we're reading so much like retroactively, right? And we already know, like, for example, we already knew that the earth wasn't the center of the universe, right? Going into this book. But it's so impressive, I think, to read this book and read how humans have looked at the moon and how they have interpreted the moon and how it's been incorporated into their religious and spiritual beliefs and how that influenced their culture, and how intertwined our lives have been with the moon as long as there have been humans. Even if we didn't understand it, kind of didn't matter, right? It still did its job, and it's still, I don't know if we can call it a job, but it still did what it was going to do, regardless of how much we understood it. And here we are saying, well, actually, I'm going to go up there and I'm going to plant my butt there. Like I put my picnic chair at the beach, and that means it's mine. And I'm going to do what I want to it. And I don't know, it seems crazy to me that we're even at that point in human history, and that I am here to experience it and even contemplate this idea, because I struggle to think that even, when they're erecting these henges, that's something that was ever on their mind, because they saw them as gods. And here we are saying, no, I'm going to be the one to go and conquer this other planet. Like that, I don't know. You talk about like, it's just too much for my evolved monkey brain to comprehend. I think that might be where like my buffer power, my processing power on my chip of my brain just completely short circuits. I don't know. It's just like awe-inspiring, I think, to be in this moment of human history where we're not only looking at the moon, we're not only going to the moon, we're not only learning so much more at an exponential rate. We're like, no, we're going to go there and we're going to, I mean, I don't want to say we're going to terraform the moon, but
We're going to own it.
because
We better own it that we're going to own it, because it requires a lot of responsibility out of us monkey brains, and I really hope they do look at Antarctica as a model. So
is there anything that I missed that you want to make sure that we touch on in this book? I know there because there's a lot that we could talk about. There's a lot in this book. It was really, really thorough book. I don't think. I mean, there obviously it's easy with a science book to get really in the weeds and to like really dig deep into one topic. I mean, they're entire degrees, right? Based on really anything you could imagine. But I mean, she did a really good job of just taking us through just all of it and touching on it, and giving us like a really broad but pretty good depth overview.
she also chunked it up into different topics that if you picked any one of those, you could cover a lot more on. Just the whole evolution of gods based on nature and multiple gods through when we developed large civilizations that encountered other large civilizations and started narrowing down to one god that ruled over nature and that sort of thing. There's an entire chapter or so on that, and you can make an entire history class or sociology class out of that one. There's a lot of things that she touches on in the book that are you could explore a lot more. Yeah.
Absolutely. And for the room, is there anything that we missed? Yeah. The great what?
Not mentioned in the book. You want to tell us what it is?
Oh, yeah.
Then you led into the Fermi paradox.
You have to have that's part of the that's part of that equation. You have to have a moon. Oh.
We'll have to see, because with the discovery of the sulfur bacteria on this other planet, which doesn't have a large moon, we'll have to see how that goes. It is very closely tidally locked to its sun, though. It's got the same side facing its sun all the time. And I like to touch on the Fermi paradox after the Drake equation. So if there are so many out there, why ain't they here? That sort of thing. So, and then you had a question too.
Yeah.
What is the current theory of the origin of the moon? There's this large body called Theia. The early solar system was, the planets were starting to congeal. There was a large body about the size of Mars that whacked into Earth because things were still not settled into their happy orbits yet. And that whack into Earth caused everything to vaporize. And it recoalesced most of it into Earth with these chunks of Theia, this Mars-sized planet, down inside the Earth. You can still see their remnants. They're called large, low, shear velocity provinces, and they're down in the mantle of the Earth. And then a bunch of it that was just silica gas coalesced. Yeah, just it coalesced very quickly, rather rapidly, into the moon in orbit around the Earth, because the Earth and the moon are very compositionally the same, except that the moon doesn't have the iron core. And you can see the anorthosites on the near side of the moon and the basalts on the far side of the moon, same as the anorthosites and the basalts on Earth. But yeah, it's that theory uses the term synestia. So once Theia whacked us a good one, we became this disk of gas that coalesced into the Earth, which was still somewhat together, and all of the loose bits became the moon.
Where are they?
Yeah. So my answer to that is they're in their own ponds. We are like frogs in ponds that are only a few feet away from each other, but we can only hop inches. So, they're out there, we're here, everybody's doing just fine. Maybe we'll see some radio waves from them someday. Maybe they'll see our radio waves, but the distances are so great. We just cannot have ET showing up here. It is incredibly unlikely.
Do we think the radio waves are more likely? Oh,
It showed on Facebook that they mentioned that the radio waves from the time that we invented radios far into our galaxy. That
Oh.
radios could have traveled.
yeah.
So far,
Yeah.
it's no
Oh. Okay. Yeah, so there is intelligent life. Yeah. Yeah. We're, nature preserve sounds better.
deliveries in less than 24 hours. I mean, they could have that great benefit. Amazon deliveries in less than 24 hours. Just think. Right?
Oh, well, I might buy into the advanced civilization self-destruct theory. I might in right here, right now. I might be believing that one. Yeah. You know what? I like that. Fingers crossed we make it another solar day. I need that on a t-shirt, actually. If we're gonna start selling merch after you guys start consulting for these firms, that's what I wanted to say.
Has everybody seen my t-shirt?
Yeah, you have to see the shirt.
The sun. Lunar eclipse, where you got the moon, the earth between the moon and the sun. An apocalypse, where the sun comes between the earth and the moon.
Yeah, glad no one pitched that. Whew. Like, yeah. Oh gosh, poor Mercury. So with that, I want to go ahead and wrap up. I think you're going to be popular, so you might have to stay for a couple minutes. I hope I know. It's what happens when you're popular. Thank you all so much for your time and attention and your wonderful conversation. I was really excited to talk about this book, and I had a great time. Selfishly, I do this because I love talking to you guys, and two, I love talking about these books because my husband's tired of hearing me talk about it. So I hope you had as wonderful a time as I did today, and thank you so much. You were an incredible guest, so much fun. I think you need to do an open mic night because your space jokes are so good. I think you have a future in coming up. Like if you could have like a Hallmark card, but like all these funny space jokes and like planetary puns.
Dad, because I tell dad jokes.
And you know what? You wear it. You wear that badge, that pride. Next month, I hope you guys will join us. The last Tuesday in May, we will be reading John Green's new book, Everything is Tuberculosis. Which hit again, another book hitting a little close to home right now. And I am so excited that Bill Sullivan will be coming back to talk about it. So I hope you will join us at the end of May, the last Tuesday of May. If you're on the live stream, come join us here live at Strange Bird. Great food, great drinks. Thank you so much to Strange Bird for hosting us. Thank you to Indiana Humanities for always being a wonderful partner in this book club. And thank you to Indiana Sciences, the March for Science Indianapolis, Central Indiana Science Outreach. And thank you to our libraries and our locally owned bookstores. You guys rock. Hopefully you're carrying John Green's new book because I know it is hard. It might be hard to get. But yeah, anyway, thank you so much. I hope to see you in May and take care. Bye-bye.